So good morning. Today's lesson is all about Python programming with turtle graphics. But today I wanted to start off, it was in BBC News today that Childline has launched a brand new resource to help anyone under the age of 18 report and remove online nudes. Now, I just wanted to flag this up so that if you see any of your friends in the situation where they've accidentally or deliberately shared a nude image and they then regret it, as most people tend to, then you can use this, and within 24 hours, someone will check it, look into it, and usually, if it's hosted in the UK, it's taken down on the same day or within 2 days. It's a little bit harder if it's shared worldwide. But I just want to flag this up and say, if you are somebody who asks somebody for nudes, then don't be that person. If you ever thought why people call people wankers, it's because it's disgusting and it's seedy to put pressure on people to do something that they don't like. So don't be the person that pressurizes somebody else into sharing something that they will regret and you will regret. Equally, if someone asks you to share a nude, it does happen to boys, it does happen to girls, happens to people of any gender. The normal thing to do is to say no, to report and to block. Do not feel under pressure. It is them, the person asking you, that is being wrong and seedy and weird. I just want to make it really clear that the normal behaviour is to ignore and to block and to report. And the school's on your side and the law is on your side. Okay? So now that we've got that very much in the public attention, let's move on to today's lesson. So turtle pens, colours, fillings and circles. Definitely not drawing any nudes in today's lesson. We want to be able to change the size of the turtle that we draw with, and we want to be able to fill in with the turtle pen colour. So it kind of fits in with this week's compete.withcode.uk challenge where we're drawing shapes, although this week's challenge doesn't involve changing the thickness of the line. So you could add that in as a challenge if you want to. You can change colours. We've talked about hexadecimal, so you can say turtle.pen colour green, or you can have hex in here. So the hash means that it's going to be a hex code, 2 digits for red, 2 digits for green, and 2 digits for blue. Yeah, we know we can have multiple ones. I don't think that's particularly helpful. I think it's more useful to just get started straight away. Now, with this lesson, you don't really have a starting point. So you've just got to launch straight in, drawing some lines. So I will go through a start point for you, but I won't share the code with you. So we need to import turtle to have the canvas to be able to draw. Let's plop that over here, that over there. Keyboard shortcut is Windows and left, Windows and right. We need to make a turtle object. In the PowerPoint they called it Alice. I'm just going to call it T because I'm lazy and I don't like typing too much. Turtle.turtle. And then T dot forwards, let's just move forwards by 100. So if you want to recognize this syntax, this is what you'll see in the PLS, the programming language subset or whatever it stands for in the exam. Something that represents a turtle, for us that's T, and then something that represents width, that's a parameter, that's whatever you want. So I'm going to say T dot pen size, put in a width of, I don't know, 10, and it will draw a nice thick line. So your job is to try and draw each of these and put in a screenshot of your code and your output. The worksheet only says output, but I want to see your code too. All right, you will find this in, where are we? It's CT, so it's Algorithms and Programming 6. We are on CT33, and it's CT33 examples. Just to confirm, activity 1 is a bit more complex than the code I've got here. Activity 1 asks you to use a for loop so that you can draw all of these lines in one go. So we'll go through that in a few minutes, but see what you can do. Okay, so we're going to go through a solution for using a for loop to draw each of these lines. So we've got 1, 2, 3, 4, 5 of them. This one looks like it's in the middle of the screen, so maybe we'll do that one first. And then we'll just add on a Y amount and draw this one and add on a width and keep doing the same as we move forwards. We're actually going to make multiple turtle objects. So we want to do this 5 times. So we use a for loop for I in range 5 times. These lines are going to be repeated, so they get indented. Then we just need to set the pen size to I multiplied by, I don't know, what does it say in here? By 5. Now this says count and count, so perhaps we should use count instead of I. It doesn't matter, it's just a variable used for counting. So this will work, but they're all drawn in the same place. All we need to do now is just go to a particular position. So let's do t.go_to. X is going to be 0. Y is going to be, let's go for count times 5, which will kind of work. Maybe, let's go for times 10. But it'll draw a line from the starting point to where we want to be. And that's no good. So the last thing that we need to do is just lift the pen up before we teleport. So t.pen up, do the teleporting, t.pen down, and it's close enough. The example here is further apart, but you get the idea of how to use the for loop and then make this repeat 5 times. Some of you use the same thingamabob, the same turtle, to draw all of them. That also works. But it's a good indication of the fact that only lines that are indented are going to be repeated inside this for loop. So activity 2 builds on activity 1. You can use the same code for it. You just need to define a list before your for loop and then set the color inside your loop. So we'll go through a solution in a few minutes. But you can see the link between algorithms and art and code. There's some really creative projects that you can get involved with when you give the computer the instructions to generate the art automatically. So we're going to go through a solution for activity 2. We're going to build on the code for activity 1. Activity 2 just has the colors on here. So if we want to replicate this perfectly, we have to start with, I think that's red there. Let's make a list called the colors. Should be snake case, not camel case. Don't like that. Let's go for red, and then green, and then, I don't know, purple, is it? Blue. It's not really blue. Purple and pink, maybe. I don't know. You can put the hex codes in if it's not quite right. And then we just need to set the color, t.color, spelt the American way, because this is a built-in function from the built-in module in the Python set of libraries, which uses the American spelling conventions. But we're British. We made the variable called the colors, so we're going to spell this with the British spelling. Okay, the colors is a list. We want to select an item from the list using the same index that we've used in our for loop, which is count. So now, the colors aren't exactly the same, but you see the idea. So we're going to go through the first part of activity 3. We need to import the turtle module. Okay, so we need to be able to draw a polygon, and this was 2 lessons ago, I think. We had to define a procedure that would let us draw a polygon with any number of sides, so probably num sides, at any position, so x and y. So let's first of all teleport, so we'll go to the x and y coordinates. We can't do that unless we lift the pen up first and then put the pen back down again so we can draw after. Once we've teleported to the right position, we should probably find out how big the polygon is. So let's put size in there as well as another parameter. So here we go, t.forward. I can't remember if it's forward or forwards. We'll see when we get the syntax error or the runtime error. We'll move forward by this amount. And we want to do that repeatedly. So for I in range num sides. That should repeat 4 times if we've got a rectangle. Next, we want to rotate. So let's go round by, 360 degrees in a circle. 360 degrees divided by the number of sides we got should mean that we go the right amount. Now, will this work? I've got no idea. When we run it, nothing happens because we've defined the procedure, but we haven't called the procedure. So this is a procedure, not a function, because a function returns a value and there's no return statement in here. But we do need to call it. You can call a procedure, you can call a function just by saying the name of it. We need to pass some data in. So how many sides? Well, let's go for a triangle first. Then we want to say where to put it. So it's the top left quadrant. That means x is going to be something negative. Let's go minus 100. Y is going to be something positive because it's near the top of the screen. How big? Don't know, just guessing. Let's go for 100. And now it says t is not defined on line 4. Have a think about why. So t isn't defined anywhere. We could make it a global variable in here, or we could make it a local variable inside the procedure. We might as well just make it local. So t is turtle dot turtle. Let's give it a go. All right, we've got our triangle. Then you just need to call it multiple times. This is the advantage of making your program modular, as in creating procedures and functions that you can then reuse. So that's a 5-point star. We want it to be plus 100 for x. Let's try and keep 100 for the size. Zoom across, what have we got? Oh dear, no, that's not right, is it? So we'll have to try and work out the angle on here. Or maybe, yeah, we've got a logic error. But you get the idea. You've got the hard bit of defining the procedure. We'll just have to tweak the maths until we get the angles right. So this is the last bit of help in the video. Do make sure that you save your worksheet before you upload it. And at the end of the lesson, it needs to be uploaded to Algorithms and Programming 6, which is at the bottom of the VLE. And it gets saved in your topic 1 and 6 folder if you're working at school. So it's not the end of the lesson yet, but when you've finished working, done as much as you can, it gets uploaded to Algorithms and Programming 6.